Hey, it's Saturday morning, April 2nd, 2016, and we're going to build a manometer. Welcome to Hack a Week. So here we are back at the workbench, all that tomfoolery over with, and today we're going to make a manometer. Manometer is something that measures vacuum. It's based on a couple of Greek words, one of them manos, which means rare, as in rarefied air or a vacuum, and the other one is, I believe, metron, which is to measure, and it was based on a French word from what I looked up. I'm always curious about where words come from. I think it was manometre. I don't know, my French, it is not so good, but it just basically means that it's something that, a meter that measures vacuum. So we're going to make one today with 4 little vacuum gauges, and well, come on over here and I'll show you all the little bits and pieces you need. Okay, here we go. We got 4 little vacuum gauges. I paid about $7 a piece for these, found them on eBay, and I've got some 3/16 brake line that I've threaded on the end to a 5mm size. I think it's 5 by 0.9. I gotta look that up. Got some caps here for 1.5" PVC pipe. A piece of 1.5" PVC pipe. We'll explain what that's about in a minute. Got 4 1/8" to 3/16 male adapters. Got some tubing. A couple of thread taps. This one is a 1/4" NPT thread tap. This is a 1/8" NPT thread tap. So, well, let me draw you a picture of just what's going to happen here. Okay, here's the plan. Here's our manometer. There's the gauge, and it is going to thread into one of these 1.5" PVC pipe caps right there. That pipe cap is going to go on a piece of PVC pipe about, I'm thinking probably 8 or 10 inches long, a cap on the other end, and then the 1/8" by 3/16 male adapter will go in this end, thread it in, and our hose will go to the carburetor to measure vacuum. You may be wondering what's up with this here. That is a chamber of air that will help to cushion the pulses that are going to happen when you hook up a vacuum gauge to any motor. The gauge, unless it's dampened, tends to just flutter like this. The digital ones take that flutter of low and high, and then they calculate something in the middle somewhere and give you a readout that doesn't move around. So the analog end of it is going to be a little bit fluttery, and I'm hoping this will dampen out some of the pulsations in the air, because that whole chamber will act like a shock absorber, a cushion of air. First thing I need to do is drill a hole in the PVC end cap so that I can tap it out with the 1/4" NPT tap. I'm going to drill a hole that's probably close to a 1/2 inch diameter. By the way, NPT stands for National Pipe Taper. See how there's a taper to that? Okay, let's fire up the old drill press here and punch a hole. So the PVC is fairly soft stuff. I've just got my tap and a pair of vice grips here because I don't have a holder that big. So we'll just get it started by hand. Make sure we stay straight as we can. I'm only going to go about that far and stop, and let's check it. We'll test it out with a gauge to see how the gauge threads in. Woo! Pretty close. That's good. I'll probably go ahead and seal that up with a little epoxy. Got a little bit of JB Weld, the JB Quick stuff mixed up. A little epoxy. Just going to smear a little bit on the threads, just for insurance, to make sure it's really sealed well, and screw it into the cap. Take it into where it just bottoms out. There we go. Got the PVC cut to 6-inch pieces. I'm just going to pull a rag through here and make sure that I get all the little particles out. I don't want anything plugging up my vacuum orifices. So we can glue the ends on now. A little bit of PVC cement on the piece of pipe. I'm using the clear stuff. Put a little bit on the end cap and squoosh it on there. And we just do the other end now. And we're going to stick a gauge on that end. There we go. One dampening chamber. Now we'll mount all these up to a board. I've got a board with holes drilled in it. I'm going to use wire ties to hold them in place. I found the easiest way to do this is to just put the piece of wood in a vise and then make sure that everything's nice and straight. And just to keep these from wiggling around a little bit, I'm going to throw some hot glue down in here. It's a little rainy outside today. I'm thinking I can lay the gauges right there while I do my synchronizing. So I need to just take a piece of this hose and stick one end on here. See about how much hose I need for each one. It looks like I give myself about, I guess, 18 inches of hose for each piece. Now it's time to remove the vacuum port plug on each carburetor. Once the vacuum port's removed, I can install this little nipple I made. I put a piece of rubber on there that I cut from some 3/16 inside diameter vacuum line. It's just rubber. So I made my own O-ring. That way I make sure I get a good seal against the carburetor. We'll put all 4 of those in and we can hook up the gauges. We're all set. Got the gauges hooked up. They're all connected to the nipples on the vacuum ports on the carburetors. I've got a temporary gas supply device I made here. It's just an old camera tripod, a little bit of creativity with an old coat hanger, a water bottle from a bicycle. Pop open the cap, there's your vent for the gas. And down here I've got a petcock from one I bought for the Sabre a long time ago, leftover. So I can just turn this on. And now we should see fuel bubbling into the carburetors. Yep. So we're going to fire this baby up, let it warm up for a little bit. I've got a fan over here to blow some air across the engine. Got to have something there to help keep it cool, because it's air cooled and we're not moving down the highway, so that's very important. So we'll warm it up first and then we'll take a look at the gauges and start turning on these adjusters right here to raise and lower the needle. And that's how we're going to sync the carburetors. So here's the gauges, and when I fire it up, I'm going to get it up to around 1800 RPMs, and they're going to float right around here somewhere. And you might see some differences between a couple of them. And what I'm going to do is I'll point to one, and I'll either go that it's too high or it's too low. And if it shows that it's too high of a vacuum, then we'll go back over here to the carbs and I'll show you which way I turn the screw to make the needle go the way I want it to go. Here we go. So you saw this one was a little bit too low on the vacuum. But what's going on is when you move one, you're affecting all the rest. So what I did when the gauge was reading low here, I came back here to this adjuster and I rotated it this way, And what that did was it lowered the needle. It's kind of counterintuitive, I know, but you'll get the hang of it really once you've got gauges connected up like this and you're looking at all of them, and you come back here and you one at a time just start turning on those adjusters. You'll see that as you move one to compensate for something being low, as in this one was, all the rest are going to change slightly. So you have to kind of watch all the gauges when you do it. So it's a matter of kind of dancing around back and forth across all of those adjusters while you take a look at the gauges and just get them all synchronized, get them all in the same location, whichever way you have to turn those adjusters to do so. Now in some carburetors, the older ones, you're actually altering a little barrel or a little barrel on the end of each one of the cables, the ones that have 4 cables, and you're raising or lowering the needle. That's what you're doing on all of them. You're raising, lowering the needle, allowing more or less air to come through the carburetor. Now when it's doing this at idle, you want to watch where the peak goes. My dampeners really didn't do too much like I thought they would, but you just watch the needle and see where it peaks out at and compare that on all 4 cylinders. It looks like this one's peaking at about 8 inches of vacuum. This one's at about 7, so this one's just a little bit high. So I'm going to go back there and turn that screw. I turned it clockwise. Now they're all right around 7.5. Okay, let's keep going here. We're going to adjust the idle screws now. All of them are at about 1 turn out from their seat. Now I can dial them in better later, but for now I think I'm going to leave everything alone. Now that I've got a good baseline synchronization, I just want to leave it alone for now. I'm going to lock down this adjuster. I'm going to hold the big nut with a 17mm wrench, tighten up the 10mm lock nut. Just a little snug. That's a tiny little rod there, so you don't want to strip it. And once we get that tightened up, now we can take this rubber boot, pull it back over there, and that covers it up. Well, that's about it. I think you get the basic idea. And like I said, you just need to get your gauges connected up, start turning on the screws a little bit, and you'll understand how the whole synchronization thing works. Crank it up to about 1800 RPMs, warmed up, and try it out there. Once you get it dialed in pretty well there, come back down to idle. Take a look at when that needle sweeps, at where it peaks at. Pay attention to that. It looks like my attempt at dampening those pulsations really didn't work. I could have just connected these straight to the gauges, and then it would have been about a $20 manometer. Pretty cheap, really. You can buy some really nice ones, the ones that have mercury in them. There's some that have other fluid. I don't know if they sell the mercury ones anymore, because mercury is actually a pretty dangerous thing to be messing with. Motion Pro makes one. They're about 120 bucks, 130 bucks, something like that. There's some digital ones out there. There are some that come with all of the nipples of different lengths to screw into a 5mm opening. and those sell for 80 bucks, 80 to 90 bucks. You can find them on Amazon, but this is a pretty cheap alternative. If you just go on eBay, you can find these vacuum gauges for about 6 or 7 bucks. So you can do it this way. So as I mentioned earlier, now it's time for finishing up the bike. Get it out on the road, get some drive time on it, get 100 or so miles on it, and then go through this whole process one more time. Once the rings are seated in and I've got everything pumping the way it should, because I've noticed on number 4 cylinder, those fluctuations are a little bit higher from negative to positive than they are, say, on number 1. So it could be number 4 is actually pumping a little bit differently than number 1, 2, 3. So once I get some break-in time on it, that'll certainly help a whole bunch, and we'll do some more work then. So that's a wrap on the synchronizing of the carburetors for now. I've got the parts in that I was waiting for to finish up things like the air box, to get the air box on there. When that's on, doing another synchronization may end up being a little bit easier, because the airbox helps out with even airflow on all 4 cylinders. Big advocate of the stock airbox. Those pods are on there now just because they came with the bike and they're keeping the crud from getting sucked in while I work on it, but they're not going to stay. So what else? I guess that's about it, and we'll get the front brakes going and keep on trucking on the CB750. So that's it for this week. Thanks for watching. Thanks for all the donations. Much appreciated. And thanks for sharing. And until next time. Hey, it's Saturday morning, April 2nd. What year is it?